4-3. That's a mistake now. It's not 4-3. What is it? 3-2? 3-4. I mixed these up. Good morning, 8th grade. We are going to wrap up our very last classwork assignment that we just had. Why does it seem so crooked? Maybe that's okay now. I don't know. We had some submissions, so we're gonna talk about it. And what I need you guys to do is give me 3 integers and give me 5 rational numbers, and we'll list it right here. Actually, let's do integers over here, and let's do rationals over here. And you could just chat them as you think of them. All right, so that's that. Let's see, 3, 4, should be A2, A2. Okay, we're ready to rock and roll. No one yet? Okay, I will stand by, and hopefully you guys are awake. Hey, how are you, Mr. Casamento? No one's here yet. Okay, good morning, Ivan. As soon as you get a chance, buddy, I need you to list at least 3 integers. I'll take more. And at least 5 rational numbers. And if you forgot what integers or rational numbers are, you may look it up. I don't have a problem with that. Good morning, Ruby. I need you guys to list 3 integers and 5 rational numbers, please. You can look it up if you have to. Good morning, Kevin. I'm waiting for chat to give me examples of integers and examples of rational numbers. It's going to lead us into analyzing the last task that we just did. You guys are allowed to look it up if you want, because these are concepts that you would have learned in your earlier grades, which we need to refresh before we do the 8th grade one, okay? Okay, Kevin, is that for integers or rational numbers? I just realized that I did that. Rational. I'll just put, yeah, whatever. Integers? Okay. So let's put that down. He says -5, 1, and 5. Okay. Why are those integers? Explain, please. And Ruby and Ivan, if you would be so kind as to contribute more integers and to agree or disagree with Kevin that they belong there. Hi, Dagny. We are just beginning our warm-up, really. Kevin has supplied us with a few integers. I'm waiting for him to explain why these are integers. I'm also waiting for chat, which would be you, Ruby, and Ivan, to agree or disagree with him and actually say why do you agree or disagree. And I'm also waiting for lists of rational numbers, please. You guys are allowed to look these up because these are things that you would have learned previously. And we really like to look at the big picture, should review them because we have to talk about that now. And that's okay, Kevin. I said you can look them up, but I do need to know also why are they integers. So if you have to look that up too, you can do that. Dagny, are those more integers or rational numbers? You gotta tell me when you guys Chat the numbers. Tell me what category they go in. Hi, Thais. We're going over the warm up right now. So chat, do you guys agree that the numbers that Kevin and Dagny put in this column belong here? And why or why not? And then I need examples of rational numbers. Please tell me why you agree, Thais. Why do you agree with these? Okay. Thais is saying that she agrees because integers are supposed to be whole numbers. Okay, so let me ask you a question. If they're supposed to be whole numbers, how come these are included? And should they be included? Integers include all negative whole numbers, 0, and all positive numbers. Okay, there you go, folks. That's a definition. So it's not just whole numbers, it's positive and negative whole numbers, and then we also have 0. And the reason why we have to mention 0 is because 0 is not negative and it's not positive. Nice job. How about rational numbers now? Because I'm really happy that you guys were able to put this together, but this one is actually a little bit more important for us to review because of the task that we just completed and what you may or may not have discovered. So let's do it. If you guys have to look it up, please, because this is something from really 6th and 7th grade. And it's okay if you forgot, but I need you to work on it now. Okay, let's see what we got here. 7/8, a third, 4/7 are rational numbers. Would you guys agree or disagree with Thais, please? And can we get more examples up here? That would be even better. We have a third, 7/8, 4/7. Okay. Dagny agrees. Why do you agree, Dagny? And can you give us more examples? Okay, guys, so I need a couple of things from you guys right now, okay? And we have plenty of people here. Number one, I need more examples of rational numbers. If you notice with integers, you gave me a nice blend or combination. It's not only positives, it's not only negatives, and then you also included zero here, right? So there's a nice blend that really represents what integers are. We don't leave anything out. Now over here, this is a good beginning, but there are many more examples that we could give that it will be very representative of what a rational number is. And then Thais gave us a definition for integers, so we're going to need some type of definition over here as well, okay? So those two things that I need right now from chat before we stop the warm-up. A definition for rational numbers and more examples that will truly represent what a rational number is, okay? If I want to represent humanity, I'm not going to pick only one country to represent it. I want to represent it with all the, maybe a sample of every country so that it truly represents all of humanity. All right, so that's basically what I'm getting at here with the rational numbers. Okay, right now, this is a very limited view of what a rational number is. I need more examples. Okay, and that's everybody in here should be participating, not just one person, not just two people. All right, come on, guys. Let's see what we got here. 3/4, 6/8, and 1/16. Okay, so those are actually I'll put them up here, but if you take a look at like I'll even put them like right here. You see how they look a lot like the ones that were already given? That's not really like diversity. I'm looking for more diversity with the list that you guys give me. And don't forget, I also need a definition, guys. Thank you. All right, let's see. So I have a question, Thais. The first one and the last one, those are mixed numbers, correct? So there's a little bit more diversity here now. It's not just regular fractions. Now I see some negatives, I see some mixed numbers. I see a top-heavy one where you did 4 over a -3. That's a top-heavy one. And then, let's see. How about these, guys? Do you agree with these? And if you agree with these, then I'm going to ask you to focus on a definition. Because I think if we could do the definition, then I think that there's a few other examples that will make sense to you. So do you guys agree or disagree with Thais's numbers? I didn't hear anybody agree or disagree with Dagny's, so I need that also. And then I need a definition. I mean, so far, what you're doing is pretty cool. I mean, if somebody was to look at this. Yes, Mr. Casamanto, I believe that's our attendance right now. I think if someone was to look at this, they could actually come to some conclusions just by looking at the numbers as to how integers and rational numbers might be different. However, I'm going to throw out a little clue. They also have something in common. So let's work on a definition for a rational number. Let me hear what you guys think. And like I said, you could look it up, but make sense out of it and put it in your own words. Okay, Thais is saying that rational numbers are fractions and they're also decimals and they include positive and negative. Okay, so that's interesting. You're telling us what they will look like. What are they though? And based on this, how about we alter some of this? Like for example, this one is the decimal 0.75, right? 75 hundredths. So now we have a decimal in there. We have a negative, we have a positive, we have fractions. Are we missing anything? And I think if you come up with a definition, you guys will know what's missing. Because there's a couple of things that are missing to adequately represent a rational number. We're almost there, guys. Keep going. Ivan, Ruby, I haven't heard from you yet. Please participate. Kevin, you did participate in the beginning, which I really appreciate, but I need you to come back into this conversation. Ah, okay. Rational numbers are ratios. Now that's actually another math word. I don't know if you remember what a ratio is. The word ratio is definitely in the word rational. So let me challenge you guys. If rational numbers are ratios, then what are the two things that we're comparing? Because in a ratio, there are two or more quantities that are being compared to one another because there's some type of relationship there. So for example, if 7/8 is a ratio, what are the two things that I'm comparing? Okay, nice, 7/8. Now we don't know what the 7 represents and what the 8 represents right now, but we are definitely comparing the 7 and the 8. And what is 7 and 8 an example of? 7 and 8 are both blank. What are they? They are whole numbers. And what did we say whole numbers were specifically in this warm-up? Whole numbers, if you include positive, negative, and zero, are called integers. Exactly. So that means that a rational number is a ratio of integers. And so in this example, I take the two integers 7 and 8, and if I divide them, if I say 7 divided by 8, all of a sudden I have a rational number. So now that being said, now you guys have a definition. A rational number is a ratio of integers. Now, you guys told me that integers were positive numbers, negative numbers, and zero. And yet, there's a few examples that still can go here. So what else can go here? Nice job. I like what you guys have done here a lot. And it's going to help you understand the overall lesson of this task that you guys were attempting. Okay, 0 and 1, beautiful. Now, is it true that I could write 0 as a ratio of two integers? What would it be? What's one example? 0 and, oh, wait, you put 0 and 1. So does that mean you want me to do this? Or do you want me to put 0 and then 1 separate? So like this or separate? Separate, okay. So let me put that, we still need to fill that in, and we'll put 1 over here because 1 as a rational number could be written, it could be written as 1 over 1, can't it? So how about 0? 1 over 1 is 1, so 1 is rational, good job. That's a whole number. How about this one though? 0, can it be written as a ratio of two quantities? And still be 0. Oh, ouch, ouch. Okay, to be fair, it absolutely makes sense why you would say that, because 1 divided by 1 is 1. So you would say to yourself, oh my goodness, well then doesn't it make sense that 0 divided by 0 is 0? Unfortunately, we cannot say that. 0 in the denominator is actually undefined. So I'll put this, and that's for any number up here. It could be 1, it could be 2, it could be 0, but 0, and this is something that you would explore in higher mathematics, okay, not in 8th grade. If we had time, we could, and I don't have a problem with that. But 0 in the denominator is undefined. 0, okay, beautiful. Let's do that then. You could put any whole number here. You could put any whole number here, and you would get 0 because what is true? And I can help you out real quick with that. 8 divided by 4 is 2 because 2 times 4 is 8. 0 divided by 1 is 0 because 0 times 1 is 0. Okay? All right. Nice job, because now you have whole numbers, you have 0, you have negative numbers, you have fractions, you have decimals here. Now you are adequately representing rational numbers, and you've given me definitions. A rational number is a ratio of integers where 0 is not in the denominator, and you told me that integers are whole numbers, which includes positive and negative numbers, and 0. Excellent job. Now, this means that we need to actually talk about this task now, okay? Because you're finally ready. So let's move to the big board, and I want you to tell me there were two questions, right? There were two big questions in this task right here. Number one, they wanted you to list rational numbers. Wait, did it say rational numbers? Yeah. They said list rational numbers that would be close to the value of the square root of 2. And if I'm not mistaken, Thais, the last class, you told us that, I think you said 7/5 was close. And what does 7/5 equal, guys? Yeah. Yes, you did say that. 7 divided by 5 was 1.4. And when we did 1.4 times 1.4, we got, I think, 2.96. Do you guys remember this? Now, also, okay, yeah, I need to move to the next word because we're going to run out of room. So just give me a second. There was another fraction that we looked at, the very first one. What was the first one? Okay, can you see that? Okay, it's kind of small. I guess I need to write bigger. Are you guys still there? Because you did a really good job so far, but there were no perfect papers. We need a lot of work on this task. So I want to make sure you understand. Okay, perfect. Thank you. So the other fraction that came up in last class was 3/2. And 3/2 is, we said 1.5. So if we tried 1.5 times 1.5, what did we get? I think we got 2.25, right? 2.25, yes. And we said this fraction is closer to the square root of 2 than this one is because 1.96 is a lot closer to 2. Remember, you're trying to get the value that is under the radical. When you do the number times the number, you are trying to get this number. The goal is for this number to be close to that number. Because remember that this is supposed to represent the side length of a square, right? And what do you do to get the area of a square? You just multiply it side by side. Okay. So now, the first thing that you were supposed to do in the task is you are supposed to actually come up with more of these. And nobody did that. I need you guys to come up with more fractions. Actually, Thais, I think you're okay with number 1. It was number 2 that we need to talk about. I sent it back to you. I don't know if you saw that. So for number 1 in this task, please come up with more fractions that you could test to see if you get even closer to the value of the square root of 2, or exactly when you multiply the number by itself, you get exactly 2. And that leads us to number 2. Do you get an exact 1? Is there an exact answer? Is there a number that you can multiply by itself and you are going to get exactly 2? And a couple of you had written out 2.0, which is great because you're showing me that it's exactly 2. Was this possible? Did you find it? And that's what you're supposed to do here. So I need everybody to take this time right now. Wow, time is up already. You're going to take a look at this assignment again, and you're going to fix it and resubmit it. Because we have to answer this question. This is a very, very important question. Because if you cannot get an exact answer, then we have a math dilemma or definition that we need to explore. Okay? If you cannot. If you can, then we need to know what it is. Any questions? I will post this video with the assignment in case you need to review any part of it. No questions. Okay, so we're going to stop there unless anyone else has questions. I do have office hours from 10 to 12. So if you have any questions or there's something that you want to make up, then you are more than welcome to join those office hours. I hope you enjoy the rest of your day, and please continue to work hard, okay? We still have a month left. Don't fall apart. Okay, ciao.